Hello, geometry students. This is Mr. Fugay, and we are going to look through a couple triangle sum word problems. So we're going to take the concept of the triangle sum theorem, the idea that all three interior angles of a triangle must always add up to 180, and we're going to apply them into some verbal descriptions where we have to develop some equations. So we're going to do 4 examples in this video. For a couple of them, or actually for any of them, if you would like to try the problem first, make sure you pause before I go over the problem, see how you do with it, and then you can review and revise as you need to. So for the first one we're going to look at, we're actually going to start with number 2. Number 2. So in triangle ABC, our first description is that angle B is 6 times as large as angle A. Our second description is that angle C is 24 degrees larger than B. What we need to do is to find all the angles. So we need to create an expression for angle A, angle B, and angle C based on what we have here. So right off the bat, we know that B is 6 times as large as A. So we're going to take 6 and then multiply by whatever angle A is. Now we don't have a description for angle A, so we're going to need to give it a name. So we can just call it a variable. You can use the letter A if you want, but for the purposes of this, I'm going to go ahead and call it X. So angle A is just going to be X, and that makes angle B then 6 times X. Now this will be important because now in this next description, C is going to be equal to 24 more, so larger means plus, and then angle B. Well, we now have a description for angle B, and that description is 6x. So we would say 24 plus 6x is what I will do for C. Once you have an algebraic expression for all three angles, all we now have to do is take all of this and add it together. So x plus 6x plus 24 plus 6x equals 180. So if I were to put those together, we have 6 and 6 is 12, plus another x is 13x, and then we still have that 24 equals 180. So if you want to write it all out first, by all means, you can certainly do that. But I'm going to go ahead now and do my algebra. So we'll take that 180, subtract that 24 away. 156, divide both sides by 13, x is equal to 12. Now what we need to do finally is we have to take that 12 and we've got to plug it into each of these expressions. I personally would plug them in independent of each other and then check to see if the answer is correct. So my first angle will be 12. 12 times 6 is going to be 72. And then really, if you think about it, we'll take that is 72, add 24 more, and that gives us 96. Now, as a quick verify, you can take 12, 72, and 96 to make sure it adds up to 180. That's always a good way to verify if we are correct. All right, let's try another. Number 4, the vertex of an angle of an isosceles triangle is 2 degrees less than 5 times one of the base angles. Find the angles. So if you haven't talked about this yet in class, you will very soon. And that is an isosceles triangle has 2 equal angles and 1 non-equal angle. So what we typically call the vertex angle, well, that's the non-equal angle. That's the one that's going to be different. Whereas the base angles, so the base angles, these are going to be our pair of equal angles. So if we want to create expressions for this, I'll call it, why don't we call it angle V for vertex, angle B sub 1 for base 1, and angle B sub 2 for base 2. Now we know that B sub 1 and B sub 2 are going to be the exact same expression, so keep that in mind. So it says the vertex of an angle is 2 less than 5 times one of the base angles. So we don't have a description for the base angle, so we're going to go ahead and call B1x and B sub 2x. Now we can create an expression for the vertex because it is 2 less than 5 times one of those bases. So it'll be 5x minus 2. Remember, when we say 2 less, we're subtracting 2 away. So there is our setup. So now we can create our equation again. We're still going to use the triangle sum theorem because even in an isosceles triangle, the 3 angles must add up to be 180. So 5 plus 6 plus 7, that's 7x minus 2 equals 180. Then we'll get 7x equals 182. And finally, x is going to equal 26. Plug these in. So our vertex angle is going to be 128 degrees, and our other ones are going to be 26 degrees when I do that. All right, we're just going to look at a couple more. Like I said, we're going to do 4 totals, so we're halfway there. So let's go ahead and actually just go right to the next one, because this one involves some fractions. So in triangle ABC, it says angle B is 1/2 as big as A, and C is 3/5 as large as B. So this is very similar to the first example we did, except we're now dealing with fractions. So angle B is created, its expression is created in terms of angle A. We don't have a description for A, so let's go ahead and just call A x. So B is going to be half as big of A, so we would express that as 1/2 times x. Now, angle C is the important one we got to think here. It is 3/5 as large as B. So what I'm going to do is I'm going to take 3/5 and I'm going to actually multiply it by the expression that I have for B, which is 1/2 x. So one thing I would probably do before we set this problem up is why don't we go ahead and simplify this? That just then means it's actually going to be 3/10 as big as, well, A or x here. So now we can create our equation. Now I might need a little bit more room, so let's go over here to the right. So we're going to end up, and I'll write this one out. So x plus 1/2 x plus 3/10 x equals 180. Now, I've mentioned in class about this fraction hack, a way for us to get rid of fractions if we don't want to do common denominators and all of that stuff. You could make this 10 over 10, this you can make 5 over 10, and do that whole thing. There's nothing wrong with doing that. However, if I were to just take this entire equation and multiply it by 10, we can also write it like this. So it would be written as such. Now we just have to take the 10, the 5, and the 3. That gives me 18x equals 1800. So when I solve this, I get x equals 100. Now we can go and plug this in. So angle A, which assumingly was going to be the largest angle because of the other ones being fractions of it, it's going to be 100, it's going to be 50, and then when I plug the last one in, I'm going to get 30. So we've done 3 examples thus far. One was kind of just a run-of-the-mill type question. Our second involved isosceles triangles and some vocab, and this one involves some fractions. So for this very last question, we're going to go all the way down to the end, and let's take a look at number 12, one of the last ones here. Same thing, this is going to have some fractions, but it has something a little bit of a different twist here. So one of the angles, I guess we'll call it angle A, we can do that, is 4 degrees larger than another angle. Why don't we call that angle B? Again, you don't have to do that, but let's do it. So we're going to say that angle A is equal to 4, and then larger means plus, and then whatever we want to call angle B. So let's actually create our list here as we've been doing. So I think the way that I've read this, I've actually created angle B as the one that's not being described. So we'll go ahead and just call that X, and now A can just be called 4 plus X. Now this is where we want to be careful, because the third angle, which I guess we'll then call angle C, is 1/4 as large as the sum of the first 2. Well, the sum of the first 2 is essentially me taking 4 plus X and adding X together. So the sum of the first 2, let's write that in green to match that up. Sum of the first 2 is going to actually be 4 plus 2x. So that's what I mean by sum of the first 2. And since it's 1/4 as big, we'll go ahead and make it 1/4 times that. So once again, like all the other examples, we have all of our descriptions. We'll set up our triangle inequality, our triangle sum theorem, my apologies. That's a preview of a coming attraction there, triangle inequality theorem. And this one we got to be very careful with because of the algebra, because of the 1/4 being multiplied. And notice it's times the quantity. So let's think about what we want to do here. I think let's go ahead and combine some like terms. We have 4 plus 2x plus, now we need to distribute this. So that's going to be 1 plus, and then that's going to be 1/2 x equals 180. If you want to, as I said, you can do the fraction hack here. You can multiply everything by 2. But I'm going to try this one differently. We're going to do this without the fraction hack. So we're going to adding it 5. 2 is the same thing as 4 over 2. So that would give me 5/2 when I add a half to it. So again, you go ahead and multiply by 2 if you feel like that's something that you'd rather do, but I'm going to stick to this. So we're going to subtract, we get 175. And the reason is I wanted just to point out that if you have a fraction times x, a quick way to be able to divide it or to get rid of it is to multiply by its reciprocal, because now the 2's cancel, the 5's cancel, and so x is going to equal whatever 175 times 2/5 is. And that's going to give us an answer of 70 degrees. So plugging those back in, it looks like angle A will be 74, angle B will just be plain old 70, and then the last angle there, if we plug that in, is going to give me 36 degrees. So there are 4 examples of how we can create verbal descriptions based on the triangle sum theorem. Now your task is to try some additional problems from this same document to see now how you would fare in these situations. So thank you for watching this video and best of luck to you in your practice.